So, if we look at the benefits, it's reducing latency and for that entire closed loop, both coming from the machine as well as going back to any controls and so forth. And that can be critical for high speed machinery, safety systems, and so forth. If we look at improved reliability, again, it's reducing that risk. So if your cloud or your internet goes down, you can still be running. Some of the bandwidth optimization, being able to summarize some of the information because you're handling some of that processing locally, so you can send up only what you choose instead of having to send everything back up to the cloud. And then enhance security because you can do a lot of the most important things locally instead of sending all of the critical information elsewhere again. And so those are some of the key benefits. Frank, can you share your thoughts on those?
Yeah, and I'll go to that enhanced security, right? Because now, to your point, especially today, you want to reduce that attack vector, that surface. So if you're doing everything on your OT network or operational technology, so we're talking the sensors, the PLCs, and whatnot, you don't have to harden all those points. You should harden all of them, to be clear. But when talking exposure to your bigger systems, especially your IT systems, you can go ahead and concentrate a lot of your work right at that ingestion point from the OT to the IT.
Mhm.
Um, and the reliability is the other thing I'm just going to touch on because it happens. You can run for years and never have an issue with your platform or your cloud, but it's that one time that it goes down. You still got to be able to operate the systems and the edge devices uh, that you have should be able to compensate, hold on to the data, still work without that without needing to hit the cloud or that central gateway.